one thing is essential. To accelerate decisions, you need innovation that fits the mission. We innovate from AI to zero trust. We integrate using open APIs that you control. We automate with smart solutions so warfighters know and act faster. Your mission, accelerated. Tomorrow's challenges, anticipated. Win faster with Booz Allen.
Hello and welcome to the Emerging Tech Horizons podcast. I'm Arun Serafin, the Executive Director of NDIA's Emerging Technologies Institute. Today we're going to talk about drone swarm technology. My guest today to help explain this technology is a returning podcast guest, Dr. Daniel Gerstein, who authored a recent RAND paper that provided a technology and risk analysis for unmanned aerial systems, or drones. Dan's a senior policy researcher at RAND and professor of policy analysis at Pardee RAND Graduate School. Previously, he served at the U.S. Department of Homeland Security, DHS, as the acting undersecretary and deputy undersecretary in the Science and Technology Directorate, where, among other things, he helped manage $1 billion S&T budget. He's got extensive experience in security and defense. He served as a senior executive service government civilian, also in uniform as an Army officer, and in industry. He's also an adjunct professor at American University in Washington, D.C. Dan, thanks for joining the podcast again.
Thanks, Arun. Good to be here.
So today we're going to talk about a report from RAND's, I'm holding it up here, RAND's Homeland Security Operational Analysis Center, and it's called Emerging Technology and Risk Analysis, Unmanned Aerial Systems Intelligent Swarm Technology. We'll put a link to it in the text box. So Dan, can you tell us a little bit about the center, and you're a co-author of this report. Tell us about your co-author as well.
Great. Well, thanks for having me. I'm looking forward to a good discussion. So the Homeland Security Operational Analysis Center is what we call a federally funded research and development center that is run by the RAND Corporation on behalf of the Department of Homeland Security. We essentially have a 5-year contract that allows us to support the department. We're one of 2 federally funded research and development centers that the department has. We do these kinds of studies. We help them think through hard problems. And this is one of a series of hard problems that they've asked us to look at. This particular study, we are looking at 10 different technologies, trying to understand how these emerging technologies could impact on DHS missions. Now, my co-author, she's no longer with RAND. She got a terrific job. She works now at the United States Air Force on the air staff, and she's in their studies and analysis organization. So she's well suited to continue to work on very technical and important issues of the day.
That's great. Okay, so to dive into the conversation, first, to level set for the audience, the report delineates between 2 basic categories of drone swarm technology. The first is surrogate swarms, and the other is intelligent swarms, as I understand it. Could you share what the difference and distinctions are between the 2 of them?
Yeah, so we came up with this idea of a surrogate swarm. And we did that because we wanted to segregate that thought from the intelligence swarm. Let me start with the intelligence swarm and tell you what's so unique about it. An intelligence swarm would have members of the swarm, drones, that would actually be able to communicate with each other, that would be able to exchange information, that would be able to change flight plans based on threats to the swarm and to individual members of the swarm. And so they're actually artificially intelligent, capable, and they are very unique in that way. So take the swarming technology itself. Swarms, the idea of swarming at a target has actually been around for quite some time. In World War II, we had the swarming done by bombers that were coming from maybe different locations, meeting up, and then attacking the ball bearing factory in Germany is an often cited example. More recently in Afghanistan, U.S. forces in the early part of that conflict in 2001 were using swarming techniques where you had multiple operators, each flying a different system, and they were coordinating the times that they were intending to attack a target. So that's multiple operators and multiple drones. But we have another type of surrogate swarm, and that is where you have a single operator, perhaps controlling multiple 10, 20 different drones simultaneously. Those are different than the intelligence swarms because that technology is already mature. And what our customer asked us to look at was look at the high end, look at an artificial intelligence enabled swarm and see what that technology could mean for the future of drone warfare, of homeland security. And so that's what we did. And that's why we delineated into surrogate swarms and then intelligent swarms.
And so for the purposes of, thinking about commercial applications, defense applications, what are some examples on the commercial side of each of these kinds of surrogate or intelligent swarms?
Well, I mean, swarming has again been used in various ways. Agriculture comes to mind. I'll use a number of cases in point there, but we think about for agriculture being able to deploy pesticides, for example, and you could use a swarming technique and that would be able to be launched and guided from an operator who is on site. So, that's one. We also know, for example, in agriculture that University of Nebraska is experimenting with the intelligence swarm technologies. The assumption is they haven't given a lot of detail on what they're looking at, what specific applications, but we know that it has to do with being able to say, for example, where might you need more water deployed? Where might you, have better conditions for certain types of crops? So those are the kinds of applications that could be looked at. You could also see for civilian applications, the Department of Homeland Security would be interested in these drone swarms to be able to go out and say after a hurricane, go and be deployed in formations that would allow them to see what damage had occurred and where help was needed most expeditiously. So those are the kinds of civilian applications that one might think of. Taking this into, I'm sorry, did you want to?
And then just on the surrogate swarm side, then at the low end, it's summertime. I go to my 4th of July celebration. I watch the Olympics. Those are surrogate swarms. Those aren't typically intelligent swarms.
Right. What they are is actually swarm technologies where the flight plans have been calculated and they don't really deviate from those. And they are controlled by normally a single operator, but they stay away from each other. They don't want to collide with each other. But they are only controlled by the operator. They do not control themselves, which is very different than an intelligence swarm where there's ongoing communications that these individual members of the swarm can communicate with each other. They can communicate with a base station. They can change their flight plans in response to threats and vulnerabilities that they might see in their flight plan. They can optimize their flight plans to whatever mission they're intending to accomplish.
So I'm getting a sense of it, but just to drive it home, we were talking about Homeland Security commercial applications. Now on the defense side, you mentioned that historical examples. DoD cares a lot about intelligence swarms and the development of technology. Why, how have they been, or how are we seeing them being used, or what do we think they'll be used for going forward?
Well, of course, anytime you can mass an effect, which is what a drone swarm allows you to do, it's of interest to the Department of Defense. And so, we, as I mentioned, in 2001, we saw it in Afghanistan. we actually saw adversaries in places like Iraq and Afghanistan employing drones in a swarming type of environment. They weren't intelligence swarms, but they were directed against targets, and that complicates being able to defend the target, and so that's why they're incorporated. We also know that there are a number of DoD organizations that are very interested in this technology. An obvious, the one that comes to mind is DARPA. They have an ongoing program that's looking at this. The Department of the Navy also has programs that are looking at intelligence swarming techniques. Some of the swarms are modestly sized, measured in the tens of systems, and others are, could be up to, 500, 600 members of the intelligence swarm.
Yeah, and I think there was some work done by the Strategic Capabilities Office as well, right? That on swarming technologies, and they had coverage even by 60 Minutes, as I recall, on
Yes.
some of their swarm work.
Yes.
And then when you think about classes of UASs, sizes of drones, potentially swarms could get up to the biggest sizes as well. Is that fair to say?
I think it's fair to say, but there's a certain utility to having smaller members of the swarm, the elements being relatively small, because it makes it much harder to target them. One of the benefits is that they're small. Many of them have very low radar cross sections, meaning they're hard to acquire as a target. And so being able to have these these platforms that are very difficult to identify and to engage, and then have them be able to maneuver around areas where air defense systems might be, means that you have a higher probability of accomplishing your mission, whether that's taking out an enemy radar, whether that's engaging an enemy formation, whether it's conducting reconnaissance, whatever it might be. So yes, you could have a swarm with larger ones, but that might not be to your advantage. It might not be as advantageous.
Yeah, and then on a previous podcast, we talked to some folks about power beaming technologies and the idea that some of the drones in a swarm could be sort of the power stations, right, and beam power to the other parts of the drone, to the drone swarm. Some of them could be the comms nodes and be particularly outfitted to communicate up or down and things like that. So regarding the report itself, it sort of reads like an unclassified threat brief. It's an interesting approach to look at technology maturity and risk. Can you talk us through why you took that approach and what the methodology you used?
Well, in describing this, I should mention that the sponsors for this work, it's actually co-sponsored by the Science and Technology Directorate and the Office of Policy. And what they asked us to do was to think about these emerging technologies. When are they going to be mature, to understand those different capabilities? And then how might they be used in a coordinated fashion in order to do damage, in order to conduct some nefarious act? And so what we did, the first thing we were required to do was to develop what we're calling a framework. And the framework consisted of two basic terms. The first was about technology availability, and that included the science and technology maturity, the types of use cases, how it might be used, by whom it might be used, what resources were committed to it. Are there any policy, legal, ethical, regulatory impediments that might prevent its use? And then how accessible is it? Could a nefarious actor pick up that technology and do something with it? So that's technology availability. And the second term of this framework is what we call the risks and scenarios. So we looked at the threat. Who might be the actor? How might they be educated? What sorts of funding might they have? We looked at the vulnerabilities. How could an actor use it to put at risk systems in the homeland? And then finally, what are the consequences? If it were to be employed, is it a local event? Is it a regional event? Is it a national event? Is it a global event? And so, we were able to look at various technologies. For example, one of them we looked at was synthetic pandemics. how easy would it be for a nefarious actor to develop a synthetic pandemic? In this particular one, we looked at intelligent swarm technology. So that's how we came to develop this capability. So why is this important? Well, what it allows us to do is to, in a very objective manner, look at these different technologies and even compare them against each other to say, how dangerous are they? What kinds of threats do they present? What kinds of risks do they present? So we've done that now. We've actually got 4 other papers that have already been published, and we've got 2 more that are completed and awaiting publication. And we owe 4 more papers on emerging technologies.
And those are all unclassified and available on your website.
Yes, they are. And in fact, I think that's really one of the strengths of it is the idea that we are having a serious discussion about very hard topics, and we're doing it in a manner that I think is hopefully educational to people who pick them up, and they understand the complexities of Homeland Security and of how emerging technologies could be used to both challenge Homeland Security also alternatively, they present opportunities for improving Homeland Security. So understanding the two-sided nature of technology is very important.
We'll certainly drop in a link to the reports into the text box when we release the podcast. How do you feel like policymakers could make use of that methodology?
Well, what we really like about it is the idea that it is very dependent on scoping. So, when we did this analysis on intelligent swarms, we were sort of given the kinds of risks that we were supposed to consider. But it can be used across a wide variety of technologies and a wider variety of risks. Think about risks and scenarios. So it allows one to actually contemplate these very challenging questions in this objective sense, rather than, to sort of, if you will, kind of guess or not have a framework to be using. So we think it's very important from that standpoint. We do use open source material. We use a lot of academic publications. We use industry association information. We use news accounts. And obviously, many of us have security clearances and are informed by our understandings, but we don't incorporate those directly into the work that we're doing. But it does provide this common approach for understanding emerging technology.
So back on the report side, then one of your findings was that the maturity of emerging technologies, across the board, will also help the maturity of the swarm technology, because as you talk about, the swarm technology kind of sits at the convergence of things like AI and big data and Internet of Things and future G. Walk us through how you think those different emerging technology areas, which are priorities now of the Pentagon, are going to contribute to the development of these intelligent swarms.
Well, I've already talked a little bit about some of the technologies, but the idea of being able to communicate not only between elements of the swarm, but external to the swarm means that you're going to have some kind of communications. So 5G actually is a big aid here, because you can make use of the local communications capabilities, wireless type capabilities, to tie in when you're using these swarm technologies. Likewise, if we have satellite communications and we're using CubeSats with satellite-enabled stations that are able to communicate with our swarm, that allows greater reach, so that operators will still be able to communicate with the swarms. Having the Internet of Things also is important, the IoT as we call it. The IoT is made up of sensors and actuators. So sensors are what gives you the ability to understand situational awareness, to measure what's happening. The actuators allow you actually to manage things, to change settings on various electronic, digitally enabled capabilities. So the IoT is very important. Artificial intelligence is very important because we want to be able to take these intelligence swarms and have them be responsive, understand where there's a threat, respond to that threat actor to move out of an engagement area if they're being targeted. And that really depends on the communications, the artificial intelligence. And so all of these kinds of things become very important.
And so on the bio side, another emerging area, and you come from a biodefense background yourself, on the biotechnology, emerging biotechnology side, I'm thinking about this as sort of biomimetics, right? Some of the best swarms most people have ever seen are swarms of birds, right? The incredible ability of swarms of birds to navigate and honestly create these shapes sometimes. Is there work being done to look at that and try to copy that, some of those capabilities into the swarms we're building ourselves?
Well, I think for some of the surrogate swarms, especially like the ones that have been used for like the laser light displays, I think they do rely on that. But a lot of the artificial intelligence, because of this communications, gives you more of an ability for free-formed movements of the individual elements of the swarm, as well as the swarm as it moves in unison. But, there's certainly applications in nature. I'll give you an example. When we look at nature for things like strength of materials, and we know that, materials that have triangular shapes tend to have greater strength. And so, we do mimic nature where it seems to make sense. Many might consider artificial intelligence and neural networks to actually kind of reflect the way the human brain works. I think now we would say it's probably looking to go farther even than the capacity of a human brain. But
Right.
still, the idea of a neural network does kind of mimic the way you might think about how it works in the human brain.
Okay, but I'm right in saying a school of fish or a flock of birds is at some level an intelligent swarm.
Oh, yes. Yeah. I mean, it certainly mimics it. I mean, there is certainly some degree of communication that is ongoing.
Right. Okay. So the report makes a good case that the technologies are maturing, both for the drones and for all of the supporting technologies that you mentioned. All of those technologies are accelerating at a rapid pace. They're all mostly commercial, they're global, they're proliferating. On the other hand, it seems like the defenses against the use of these swarms, whether they're surrogate or intelligent, can be both costly and challenging. So what have you seen on the Homeland Security side as people are thinking about these threats, their proliferation, and what we can do to counter them?
Well, I mean, for example, we do have capabilities that have been used both by the military, but also by law enforcement that allows one to take over digital control of the system and to, say, land it harmlessly. Obviously, you have to be careful that you don't want to be, say, in downtown Washington, D.C., and do something that would cause the the drone to fall out of the sky and possibly injure or kill somebody. So you have to be very sensitive to that. One of the things that makes it very complex for a drone swarm is because you're dealing with so many elements. Take a drone swarm that may have 100 or 200 elements within it. It's not enough to take down a single drone. You have to be able to knock down enough so that you decrease any sort of adverse effects down to a manageable level. But imagine if you had an intelligence swarm and instead of just following a flight plan, they were able to actually maneuver toward the target to avoid the air defense. And so you have the complexity of a changing flight plan, numerous targets that you have to go after to reduce the effectiveness of the swarm or to hinder the swarm elements from reaching their target. So all of this means more complexity. And then now let's take it really into Homeland Security and say, you can't protect everything in the homeland. You have to understand that there are certain things that are more valuable than others, and those that are assessed to be the most at risk, that present the greatest threat, vulnerability, and consequence are the ones that you have to try to manage the most closely. And that might mean that, for example, there might be some electronic substations, power substations that you may not be able to protect, but you may have others that you say we must protect at all costs, because losing them could could it cause the rest of the grid or a large area of the grid to go down. So all of this becomes very important. This is also part of the reason why we think our methodology is very important, because it does allow you to think logically about the characterization of risks as the threat, vulnerability, and the consequence.
One of the things you highlight in the report along these lines is the North Carolina incident. Can you recount what that is for the audience?
Yeah, so I mean, this has gone on. At times we've had somebody who takes a shot at a substation. They may do a damage to a transformer, but generally speaking, it's something that is relatively manageable. And we had something like this occur in North Carolina. Somebody used a high-powered rifle and did damage, but again, they were able to work around it because it was a single substation. But imagine if it was a larger place where electricity emanates from. Excuse me. Imagine if you had, um, many drones coming in to destroy it. That could be a problem.
Right. In that case, then it's that old adage, right? The quantity is a quality all of its own. And I guess smart quantity is even worse, I suppose. In terms of what DoD is doing to posture itself, it's actually something we're going to be talking about coming up at the NDIA's Emerging Technologies Conference, both the UAS and the counter UAS side. What do you think are some of the more promising things that DoD is doing to think about some of these threats?
Well, I think DoD has recognized that drones are really, something that needs to be monitored very closely, both the production of them, who's doing it, how they're using it, but also to make use of these systems. And so the replicator program is kind of one instantiation of this. The replicator program is the intent of it is to be able to develop a number of autonomous technologies, including drones. They would be attritable autonomous systems. The hope is to have something by August 2025. And imagine the capacity, though, if you have, say, and I'm just coming up with a hypothetical scenario, but think about the Taiwan Strait and using replicator drone systems to be able to defend the strait if that became necessary. So it's just something to think about when we talk about how to use these swarming techniques against targets to be able to achieve the range of tactical, operational, and strategic effects that are intended. Along with that, of course, is to understand about the countermeasures that we would have to take, because whatever we might be able to do, others might be able to do as well. And we've seen the drones been used very effectively by both sides in Ukraine, in particular against, say, the Russian Black Sea Fleet, the naval fleet. They've been able to essentially destroy that fleet without having a navy. And then you look at Russia, who's been able to hold at risk civilian infrastructure in various cities based on having the ability to fire drones and missiles into key areas. So it just gives you some idea of the need to be able to understand your vulnerabilities and to take countermeasures against them.
Yeah, and then the range of counters that DoD is working on include electronic warfare and cyber effects against these drones. I guess the complexity of the intelligence swarms also creates vulnerabilities on their side. We've seen them invest in directed energy systems, high energy lasers, high power microwaves, even kinetic physical systems to take down some of these intelligence swarms. So moving forward, then, what do you think the next steps should be as DHS, commercial world, DoD thinks about swarm technology and even the counters?
Well, I mean, I think, both DoD and DHS for their respective missions need to really think about how to prepare for, respond to, and mitigate the effects of these systems. And, some of that's going to come down to the countermeasures against them. What kind of, I'll call it an electronic umbrella might one use over top of key targets that we are trying to defend. The other piece is to have resiliency, to have a formation that is spread out enough so that not everything is co-located. When I was in the Army, we had very large command centers with lots of very important people there, command and controlling large formations. But that is now a vulnerability that one cannot afford. So we need to think about how do we exercise command and control differently. We still need to mask the effects, but we can't do that by massing our people to do that commanding and controlling. Otherwise, we'll put them at risk. We've already seen this in a number of attacks where Ukraine has been very successful in attacking Russian command posts. There were a number of very high value targets that were killed during those engagements. And they were using different types of technologies. Some of it was certainly drones, using some swarming techniques. They were also using the ATACMS, the missiles that are very powerful. And they were massing those, if you will, swarming those capabilities as well. So all of that becomes very important as we think about the future.
And in terms of the domains, is it fair to say that the swarming technology is useful in all the domains that DoD cares about, or undersea, surface, ground, airspace? We mostly are talking about air in this conversation, but is it useful up and down, or are there places where swarming is not as useful?
Yeah, absolutely. And in fact, even in the Russia-Ukraine conflict, we've seen the use of swarming for naval surface combatants. They've been able to take, these are very, very low tech in many respects. I mean, literally, it's a boat with some sort of explosive detonators on it, and it's aimed toward a target, and it engages the target with great effect. And if you have, multiple uh, autonomous systems or even guided systems coming together simultaneously, it presents a very real challenge for a defender.
And then in terms of the policy environment, in terms of developing a regulatory environment for the use of drones, in terms of even the ethical use of drones on the battlefield and the treaty constructs that we develop, what's going on and what are some of the major issues that either government or the private sector are thinking about right now?
Well, I mean, this is one of the lessons of technology, and that is that generally speaking, the policy, the regulatory frameworks, the standards, the ethics, they generally are kind of retrofitted after the technology's already been deployed. And I would say, even with drones here in this country for civilian purposes, it took quite some time to the FAA was able to put out guidance. We had a number of airliners that were on final approach and almost collided with a drone that was being flown in the airspace. So, what it speaks to is that we need to be better about foreseeing what some of the risks might be and then mitigating them before we actually have to suffer a catastrophic loss. So I think what that really tells us is that we need to think hard about how we might put these preventative and mitigation measures in place. But it also says it's going to be quite a challenge because drones themselves, unmanned aerial systems, have already proliferated. Companies are already looking to use them to do deliveries. We're using them, in the Ebola crisis in 2014, they used unmanned aerial systems to take blood samples and fly them from the outsites where the blood was collected to very sophisticated laboratories. That eliminated a 10-hour trip by vehicle to be able to fly a drone. So we're already seeing the use of drones, and it's going to be hard to put that genie back in the bottle. So now we need to think about, what are the ways in which we'll prepare for something that might happen, respond to it if it does happen, and then mitigate whatever effects that we're anticipating.
So with that, I'm going to have to draw the conversation to a close. Thanks, Dan, for this enlightened discussion of intelligent swarms and drone technology. Again, the report is available on the RAND website. We'll put the link up, as well as the whole series looking at emerging technologies. I just want to tell people about some of the upcoming Emerging Technologies Institute and NDIA events. The second annual NDIA Emerging Technologies Conference is going to be held August 7th through 9th at the Walter E. Washington, D.C. Convention Center. Registration is now open. Exhibit and sponsorship opportunities are open. Visit ndiatechexpo.org for more information. Also, please visit NDIA and ETI's websites to sign up for our mailing list and register for our various seminars, events, and educational offerings, including our Tech 101 series. Thanks again, Dan, for joining the podcast. If you all enjoyed the podcast, don't forget to hit the like button and subscribe to our channel to stay up to date with all of our content. A special thank you to Melanie Yu and Daniel Park for producing this episode. Thank you so much for tuning in to Emerging Tech Horizons.